You want to cover mine? 3 hours of driver's ed. Okay, here we go. Overall, just looking right here, I'll refresh it. And we have a 90% average score on here. That's pretty incredible. It looks like one of them was harder than the rest. Everything's above 90, except for one problem. Any guesses which one that is? AL? They're shuffled. So saying the last one's tricky. The AL. Let's look at it. Uh-oh. Where am I? Okay. You shouldn't do that. Okay, please with me. We had ALOH3, or did we? Okay. Well, this thing just decided to take a nap for a minute. Uh-oh. It's struggling bad today. Let me reset it. So ALOH3 goes to Al2O3 plus water. I would write water as HOH if I were you, which I think most of you did because you got it right. Let me see if this connects better now. Oh, it already was. All right, good. Al2O3 plus HOH. I don't know. Personally, I'd start with the metal, but you don't have to. You have 3 OHs here. You have 3 O's here. Gets a little bit tricky. That's why I would start with the metal. Got to sneeze. Hold on. Both of those were such a letdown. So if you look here, a lot of times, if you leave O and H to the end, they'll take care of themselves. You know you have to double the metal, and it's only in one other spot, right? So my recommendation is starting with doubling aluminum hydroxide. All right, then that makes the problem here, why this is hard, you have O in this and O in this and H in H. Ultimately, this one, it doesn't matter that much which way you do it, but now you have to break them up. So how many O's do you have? You have 6 O's because it's 2 times 3, right? How many H's do you have? So O's, 6 H's. And you can fix that by just putting a 3 right here, right? Okay. When you are dealing with the decomposition of metallic hydroxides, they're usually really hard. So balance the metal, then go to your O's and go to your H's. They can be really tricky. But even that one, we were at 88%. So you battled through it and did fantastic. I guess a lot of you had 88% had the 2. 81% had that, and only 66% had a 3. I don't know what you put, maybe a 6, but oh well. I feel pretty good about it. Way higher than I expected at 91%. So fantastic. I don't know. The way I'm about to sneeze, I feel like you think I'm being sarcastic, but I'm being genuine. You did awesome. Okay, let's take out or just turn to the page, of notes we had yesterday for that little assignment. If you already did it and turned it in, that's awesome. I appreciate that. We had done how many? We've done these 3, right? Do I need to go through number 3? Okay. Number 4 is right there. Will you try it on your own first? It's butane. We actually did this in the notes, but try not to look back in the notes and do it. It's butane, which is C4H10. But means 4, ane means 2 times 4 plus 2. Plus oxygen goes to carbon dioxide plus water. This is a combustion reaction. This is a combustion reaction, which means it has its own little set of rules. Okay, when you have it done, raise your hand. Okay, we'll give you about 1 more minute. I hear it's sharp. I've never cut myself with a spatula. Yeah, it happens. Okay, I hear some mumbling, so if there's a disturbance in the force, means we're probably ready to go. So butane is C4H10 because it told me. And on the AP test and in my test, you are never required to be able to write the formula of a hydrocarbon. Like I will still teach it to you, but they'll give it to you. Plus oxygen goes to carbon dioxide and water. How come I didn't put HOH in this problem? All right. You don't need to because there's no OH on the other side. Hold on. Okay. So we're ready to go. Combustion, what do? Start with the 2 because I told you to, right? 2 times 4 makes how many carbons? 8. What do you do with the number with H? Tell your partner, not me. Put it in front of water. Then we're ready to go. I have 2 times 8, which is 16, plus 10 times 1, which is just 10. That's 26. Then I'm going to divide it in half, so I get 13. Who had it right? Okay, 2, 13, 8, 10. I don't know. We okay with that? Next is barium chloride plus sodium sulfate, sodium chloride. I know that there's a lot of me doing nothing today, but will you take the next 2.5, 3 minutes, we'll call it 3 minutes, and do that problem. Is that out of order? Is this the right one? Oh yeah, it's there. It's good. Yep. All right, you have just a tiny bit of time left. Arrow. You're fine. Just put the arrow. That's right. The arrow's here. Well, here's barium. Here's sulfate. All right, I'm going to move on in 10 seconds. Okay, here we go. Stick with me. So we have barium. I'm going to underline these. We have barium chloride. So we have Ba. Why did I underline the IDE? Because it means it's just an element, right? Don't throw an oxygen on it if it says A or IDE. So it's barium and chlorine. I'll come back in a minute. It's sodium and it's sulfate. Those are the two words. I'll come back and do the charges in a minute. Then barium and sulfate. So it's Ba and SO4. I'll come back in a second. And then I have sodium and chloride, which means Cl. Do I put a 2 because it's diatomic? No, 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 no. Okay, now I wrote all the words. Now I'm going to do the charges. I know barium's in +2, -1, +1, -2, +2, -2, +1, -1. Now we are at the point where those charges should be known. We are there. If you don't, they at least should be found by looking at your periodic table. All right, so here we go. I got to drop and swap. So it's BaCl2, Na2SO4. These already equal 0, so I don't need anything there. Then this 1 + 1, or sorry, 1 - 1 is 0 also, so I'm good. So I have all of the formulas correctly done now. So then I need to balance. I have 2 chlorines and 2 NAs, and I can fix that very simply by putting a 2 here, and the rest are 1s. All right, who had it in that amount of time? Okay. Okay, try number 6. All right. How we doing? Let's review something we've reviewed a lot and taught. If it says hydro, it means there's how many total atoms in this acid? How many total types? 2. If it has a hydro, it means a H and only one other type of atom after. So chloric sounds like chlorine to me. Hydrochloric, HCl. If you don't have that one memorized yet, like, let's do it. You're going to use it a lot. Now, Ooh, who just said that? Do you know the charge zinc? Zinc's one of the weird ones that is in a transition area, but does have a fixed charge. It's a +2. Well, those are tricky. Like I would hope that you're like, oh yeah, I remember that. Like those are close to being memorized. Put a plus. No, you have ZnHCl. I don't. You can go again. So it's Zn plus HCl. I'm literally only teaching 1 hour a day and I can barely stay awake. What am I going to do? It happens. Okay, zinc plus hydrochloric acid. Does zinc, if I put a +2 up here, do I put a +2 or do I put a 2 right here? No. When elements are alone, they don't have charges. And since zinc is not polyatomic ion, I'm not going to worry about it. So a hydrochloric acid is HCl. I have zinc chloride, which is zinc, and Cl. And then I have hydrogen. Oh boy. Please, hopefully you remembered. It's a 2 because it's diatomic. All right, now I have not balanced the charges here. +2 -1, so ZnCl2. And then you'd be ready to balance. Zn plus HCl goes to ZnCl2 plus H2. It is not correct as written. Tell your partner real quick. What do you think it should be? All right, I heard a lot of 1, 2, 1, 1s. One, two, one, one. All right. 8. Whoops, where'd 7 go? Oh well. 7, 8, 9, and 10. They're for you to do on your own. When is this picture due? By tomorrow. Now, about a third of you turned it in last night or this morning. Thank you for your patience. BB, thank you for letting me. I forgot to allow submissions. So it's ready to roll. You have 7, 8, 9, and 10. You can find them on Canvas. Does everyone know where I'm talking? I got it right here just in case. So if you go to Canvas on the modules, it's balancing from names practice. It gives you them right here. So there's 7. Copper 1 hydroxide goes to copper 1 oxide plus water. That one's tricky. All right. Anyway, take a picture of it, submit it. I will enjoy my time grading. All right. So now, oops, I need that one. Now that we're sort of a little bit better at balancing, it's time to apply the gasoline to the fire. Okay. So this is your introduction to something we will do all trimester. It has the coolest name ever. It's called Stoichiometry. I probably already told you, but it's Latin for fun with math and numbers and chemistry, and I love it. No, I don't know what it is. I think it's like Latin for stuff, and you're comparing it to each other. You're calculating stuff. Okay, this is a really important thing that's super, super easy, and that's knowing how to find the formula mass. Now, not calculating it, just literally finding it. If you can't balance and you don't know how to find masses, you're in a lot of trouble. This one's a lot easier than balancing though. So when you look at a symbol or a square on the periodic table, the larger of the two numbers is the atomic mass of that substance. You got to know that, like from now on, forever. So if you look at aluminum, it's 26.982. If you look on mine, aluminum is 26.981538. And I am fine for now if you say it's 27. Okay. The other number is a 13, which is the number of protons. We call that the atomic number. But we want to know the mass. All right. So the larger number of the periodic table is the atomic mass of an element. The atomic mass is also known as the molar mass or the Graham formula mass. Now, what you need to know is that this is how many grams there are per 1 mole of aluminum. What's a mole? Thank you. A mole is a big A number. It's a big, big, big number. I'll write it out for you. 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That's a big number, right? This name has a name, and it's where this A comes from. I don't know what you thought it was. This number is called Avogadro's. O-O-O-R-O-S number. Sorry, I started to write his name. Avogadro's number. Just stick with me. Avogadro's number is how many things there are in a mole. So what's a mole? Mole is a word that means a number, and it means a really big, 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 big number. 6.02 times 10 to the 23rd, in fact. So, like, don't, kids all year long, like, I hate moles. It's just, you don't hate dozen. Dozen's a word that means a number, right? And you think donuts. Well, when you think moles, you think of cancer or how bad you hate chemistry. So maybe it's not as fun as dozen, but it's just a word that means a number. So anytime you have a mole of something, that means you have this many things of it. So if I go back, if I have 6.02 times 10 to the 23rd aluminum atoms, they would have a mass of 26.982 grams. That shows you how light one single atom is, right? Because you take 27 and divide it by that number. That's a really small number. Okay. Now, you don't have to have a perfect concept along of that, as long as you know that you can write this number as a ratio. So for instance, if I had sodium and it was Na, I had a 13 and I had an 11. Sorry, 23, not 13. I knew that sounded wrong. 23 and 11. Which one's the bigger one? Tell your partner. 23. Easiest AP question so far. That would mean that sodium has a molar mass of 23 grams per every 1 mole of it. What is a mole? It's a lot of it. So 23 grams per every 6.02 times 10 to the 23rd atoms of it. That's what a mole is. That's what the molar mass is. Okay. Now, do you see this right here? This is 23 grams per 1 mole. Easy enough? Okay. Now, if I were to when I balance something, so like Na plus Cl2 goes to NaCl, and I balance it with a 2, a 1, and a 2. You with me? What I've been doing this whole time, I've been using the word, but we would say we have 2 moles of Na that react with 1 mole of Cl2, and it can form 2 moles of NaCl. Now, if I know this ratio, the sodium is 23 grams per 1 mole, I could say 46, that's right, that's what I did. 46 grams of Na plus whatever that is, goes to whatever that is, yeah, 71. Now I have something that my mind can deal with, which is grams. Go ahead.
So you know, like, oh wait, never mind, I'm an idiot.
It's okay. Okay. How many of you have ever heard the statement, you can't compare apples to oranges? You can't. But if you convert both of them to their value, could you compare their values to each other? For sure. If apples are $2 a pound and oranges are $1.50, you could compare, because you're now in a language that talks about both of them. You with me? We cannot, please look, we can't say a gram of sodium compares to a gram of chlorine. They don't. But their moles do. And then I can use the periodic table to find the ratio that then makes them talk to each other. So we can't directly compare something, but if they're in moles and we use the periodic table, we can put it all together. So what I would say now, I have 46 grams of sodium plus 71 grams of chlorine goes to 106 grams of NaCl. And that's something I can do in a factory. I can produce a mass of something. This is our future. Okay, so one more time, the big number is the grams per mole for one of it. So where did I get that chlorine was 71? Okay, because there are how many chlorine atoms in Cl2? There's 2. So to find the mass of this molecule, I take how many of them there are, and I multiply it by what they are. You with me? Okay, so we're going to do some basic addition and multiplication coming up here. All right, so if I have all the answers right here, it's pretty easy. If I want to find the mass of a mole of calcium nitrate, I take all the parts and add them together. So I'll do it on another screen. So I have CaNO3 2. So just breaking this down, and this is really like kindergarten level. You won't do this very often, but you have 1 calcium. You okay with that? Then I'm going to put a number in parentheses right here, and that's the mass of calcium. So looking over at the board, or not the board, the periodic table says 40.078. I'm lazy, so I'm going to round that to 40. You okay with that? Then I'm going to add. How many nitrogens do I have? I have 2 of them, not 6. There's not 3. This 3 goes to the O, but not to the N. So there's just 2 nitrogens. Nitrogen, looking at the periodic table, you look over there and tell your partner what it is. I'm sick of talking. 14. Wow, you guys are good. It is 14. Why not 7? That's the wrong number. That's the mole, that's the atomic number. We need the molar mass. Okay, plus how many oxygens are there? 6. 2 times the 3 is 6. I find oxygen is 16. And then I'm ready to find the complete mass of the whole thing. Mr. Avogadro.
Why did you choose that number? I think that's
12 grams of carbon 12. Where? Oh, yeah, sorry. I was like, what? There's no carbon on here. Yeah, it's kind of complicated, but he did math with carbon. He did math with all these gases, and he discovered they had, if they took a certain amount of them, they all had the same like mass to charge ratio. I'll show you the video because I don't know. It's math from 200 years ago, and it has to do with carbon being the base. It's actually really impressive math.
the reason we do it. We just don't understand why we do it right now.
we do it to simplify everything. Because math with 1 is easier than math of 6.02 times 10 to the 23rd. That's the fundamental reason. We wanted to find something that relates. And if we use this number, it also takes a mass of like a proton, which is to the negative 24th, but then it puts it in something we're used to, which is like an AMU, which is a 1. So an AMU is really a mole of the protons is equal to 1 gram. That all relates. I don't really understand the math, I'll be honest. Is this 140? I can't remember. 146? 164? Dyslexia got me again. All right. Have I told you I will do it this way very often yet? Like this is a slash. Just because on the slate it's tricky to lift it up. It's the same thing, okay? So whatever. All right, let's do another one. L NO3 3. Quick as you can, find the molar mass of that. Oh, I'm way off. 213. No, he was just telling you what that was. 213. 213. Anyone confirm that number? All right. Sorry, I doubted you. Okay, raise your hands if you think you can do this. Okay, this is an extremely fundamental but very important problem, or not problem, process to get good at. Because you can do everything that's hard the right way, but if you can't find the molar mass of something, you're in trouble. Okay, now what this really means, once again, is if I have a coefficient of 1 here, it means I have that much. This number, when we've been balancing all along, that number has been the number of moles in my recipe. That's the number of moles in my recipe. Yep, then if it's a 2, I would double it, a 3, I would triple it, a 4, I would quadruple, and just keep on going. Yeah, I cheated in school, don't worry. Like, that was a 7, can't you see it, Mr. Redden? It's right here. I don't know how you missed it. Just kidding. Okay, so grams in 1 mole of sugar. You don't need to do this, and this is not right. It's 180. I don't know where I wrote that. I must have asked a separate question. So I think I can assume what I would have asked. So this is what I probably would have asked. How many grams in, I don't know, 0.5 moles of sugar? And then I'll tell you, sugar is C6H12O6. All right. Oh, you got long legs. Holy cow. Sorry I kicked you. When we add all these up, we get 180 grams per 1 mole. Everyone okay with that? Everyone okay with that? Can I get an amen? There we go. All right. So but I only have half of that, it's pretty easy. You just divide this in half, right? Okay, now I'm going to teach you a process. It's going to get long pretty soon, where we use what we call the picket fence. And I'm going to say, hey, I'm asking you 0.5 moles. And then I have this ratio. There are 180 grams per 1 mole. This is extremely simple. They get a lot longer, but kind of get used to this process where you put the given that I give you at the top left, and then you take the unit that's here and move it down and over so they cancel each other out. Now I'm left with the unit of grams, and I'm going to multiply that, and I get 90. Now I know you can do that in your head, but you can't do these in your head. And that's our future. They're not bad, I promise. Like if you can step up 1 step, you can step up 5, right? Front row that had it last year. It's just longer, but not much more difficult, I promise. Okay, now let's do this a little bit different now. And we don't have time. But if we had this Na plus Cl2 goes to 2 NaCl. This is our future tomorrow. I want to know how many moles of this I can make if I have, I don't know, 10.5 moles of this. And I will show you how we do that. I take my given 10.5 moles of Na. What unit do I need to bring down here? The same unit here, mole of Na. And I look right here, and there is a 2. I want to solve for moles NaCl. So this right here has to be mole NaCl. What's in front of that? So moles of Na cancels out. I'm left with 10.5 times 2. So I get it's not complicated. Now, we're going to add grams to this as well. It's not bad. I think I'm really good at teaching this. I'm very arrogant. It started with my looks as a kid, and I've never really gotten over it. All right, please turn that paper in tonight, and we'll be ready to roll tomorrow.